Hello, please respond whether I am audible.
Yes, sir.
Okay, so let me share the screen. Okay, please respond in the chat box. I keep yourself muted. So, good evening, everyone. I am Keshav. I am currently research scholar at IIT Kanpur. So, I am taking this problem solving session of NPTEL course ME111, which is applied numerical methods. This is the week 12 of the problem solving session. So, what we have covered till now in this course, let us see. So in first few weeks, what we have seen? First, we have seen the root finding methods. First, we have seen what are the numerical methods, what are the algorithms, pseudocodes, how they are important for the aspect of numerical methods. Then we have seen some root finding methods. Then we move towards what? Linear algebra. There we have solved two kind of problem. First one was Ax equal to B type of problem, which is nothing but system of linear equations. So we have seen how we can solve the system of linear and non-linear equations. There are two approaches can be adopted to solve a system of linear equations. One would be the direct method or the direct approach, and second one is a iterative approach. So in direct method, we have seen Gauss elimination methods and other method. And in iterative solver, we have seen the Jacobi iteration and Gauss-Seidel iteration. We have also seen a system of non-linear equations can be converted to a system of linear equations, series of system of linear equation using Taylor series expansion. Then we have seen the problem which is Ax equal to lambda x type of problem, which is nothing but a eigenvalue problem. There we have seen how we can find all eigenvalues and all eigenvectors of a square matrix. There we have seen the power method. The power method gives us the absolute highest eigenvalue and its corresponding eigenvector. Then we have seen inverse power method that can be used to find the absolute minimum eigenvalue and corresponding eigenvector. Then we can use the shifting in the inverse power method to find the rest of the eigenvalues and its corresponding eigenvector. Then we have moved towards the calculus part, where first we have covered the numerical differentiation. Here we have seen the important method FDM, which is finite difference method. Then we have seen the interpolation that can be used in numerical integration. So numerical integration means what we do. First we interpolate the function, then the interpolating polynomial that we got after interpolation, we integrate and find the numerical integration. Okay, then we have seen numerical solution of ordinary differential equation and partial differential equation. Here we have seen some practical problems like heat transfer in a unsteady heat conduction in in a pipe in a 1D rod, and we have also seen the heat conduction with heat generation. Like that, we have seen some practical problems also. Then by this we have completed the calculus part. Then we move towards what? Regression and optimization. In week 10 we have covered regression. In week 11 we have covered optimization. So what we will cover in this week? This week is week 12. There the fundamental of machine learning. And ANN, artificial neural network, has a tool, machine learning tool, will be discussed, and we will solve some problems. Okay. So as an engineer, what we do, suppose we have some problem. We have some problem. Okay. So we wish to solve this problem. So what we do, we first make a mathematical model. Okay. We first make a mathematical model, and the input of this problem goes to the model, and it's give us the desired output. It gives us a desired output. Okay. So as an engineer, what we have some input, we build a model. In the model, we give this input, and we find the output or the prediction. For example, in thermodynamics, if we have the input delta Q, which is heat added to the system, and if we know the change in internal energy of the system, we can find the maximum work done by the system. Okay. So here, this is the model. Del W will be equal to delta Q minus du, and delta Q is our input, and we get the output delta W. Okay. This is nothing but the energy conservation equation. Okay. Similarly, other kind of problem we also can have, like wind turbine problem or any problem that involve heat, that involve fluid flow. So there we have some input, and we have some conservation equations, like continuity equation and momentum conservation equation. This is Navier-Stokes equation. So continuity equation is nothing but the mass conservation equation, and this is nothing but the momentum conservation equation. So by these conservation equations, we have a model. We give certain inputs, and we use this mathematical model. Then based on solution algorithm, we get the desired output. Okay. So this problem, suppose, is based on some mechanism. That mechanism is what? The energy will be conserved in the system. This problem is based on the mechanism that the mass and momentum will be conserved in the system. Okay. So what will happen when we do not have a well accepted mechanistic model? When we do not have this kind of model, means what? We do not know the underlying mechanism that is governing this problem. When we do not have a mechanistic model, but we have the data. The data generally comes from the experiments. So we only have the data, but we do not have the mechanistic model. Means we do not know the mechanism governing. We do not fully know the mechanism that is governing the problem. Okay. In that case, in such a scenario, machine learning can be an important tool, can be useful for such cases. Okay. So what do we mean by machine learning? It is made of two terms. First is machine, second is learning. So machine means what? Computer program. Machine means what? Computer program means there is a computer program, and learning means its prediction will improve with experience. Okay. What kind of experience? Mostly the bad experience when we have a large error. Okay. So if we define formally what is machine learning, so it can be defined like that: a computer program is set to learn from experience E with respect to some class of task T and performance measure P if its performance at the task T as a measure by P improve with experience E. So if its performance improves with experience, then the computer program is set to a machine learning program. Okay. So when machine learning is useful, so machine learning is useful when we do not have a model to describe the process. Okay. Or when we have a model, but the model is incomplete. The model do not give the complete picture of the problem. Okay. In that case, machine learning can be useful. Or we have a model, but it is too complicated to solve. Okay. It suppose we have a problem which require a lot of resources, computational resource to solve full-fledged problem without having much more assumptions. Okay, in that case, machine learning can be useful since the problem is very computationally extensive. Or machine learning can be useful when we have a model, but the model is ill-posed. What do you mean by ill-posed? I think we have discussed this earlier also. Ill-posed means what? Suppose we have some model. Okay, this is my model. We have it is having some input and it is giving me some output. Okay, it is giving me some output. Now, if the input is perturbed, if we perturb the input, means what, we increase or decrease the input by a small value of psilon. If it outputs increases or decreases drastically, then this problem is said to be ill-posed problem. Means what, generally what should happen if we have a small perturbation in the input, that small perturbation should be reflected as a small change in the output. But if it not having so, our output changes drastically, then this kind of model is said to be a ill-posed model. Okay. So what is the difference between the prediction from the traditional model and a machine prediction from the machine learning? So traditional models are generally mechanistics, means what, they are developed based on some mechanism. Okay. While the models in machine learning are empirical in nature, means what, they are data driven, they are derived from the data. They may have some physical bias, but they are mostly data driven. In the traditional models, we have problems, we have a problem, and the input of the problem is known. And what we try to find, we try to predict the output in traditional model. But here what we have, machine learning problem, we have a input and we have a known solution for that input. Okay. And what we do, we predict the value based on the input and the known solution. Then we check what is the error involved, or based on that, based on the difference between the known solution and the prediction, we optimize our model. So the traditional models are rigid. What do you mean by rigid? Rigid means what? The model is based on some conservation principles like mass conservation, momentum conservation, energy conservation. So these models are rigid. Means what? We cannot change the mechanism that is governing the problem. Means what? We cannot change the model. I hope I'm audible. Hello.
Hello.
Okay. So I'm audible. So these models are rigid, but the algorithm to solve this model or the boundary conditions or property that may change. but the model will be rigid. But here in the machine learning, the models are flexible, or the models we want to improve. The model only we want to improve with experience. Okay, especially the bad prediction. Based on the bad prediction, the model will change to optimize it. So since the model is rigid, we generally have deterministic in nature. The traditional models are deterministic in nature, while since these models are predicting the value, machine learning models, so they are predicting the value, so some probability are involved with the prediction. That's why these are said to be, these are mostly probabilistic in nature. So what a mathematical model do? A mathematical model provides an answer to a question. The answer is output and the question is input. Okay. So in machine learning, the output is called as label and the input is called as feature. Okay. So in machine learning, the computer program uses training data. What is training data? This is question plus answer, both. Means what? Feature and label both. Computer program uses training data to learn the model and then answer to a test data or our unseen data. So suppose we have the n number of data. This data will be used to make the model, and once the model is generated, suppose we give some unseen data, then it will predict its output. Okay. So type of machine learning. Machine learning can be broadly classified between two categories. First one is supervised learning. Second one is unsupervised learning. In supervised learning, what we have, finding the label of the test data using features and label both of the training data. So in the supervised machine learning, we have the features plus label in the training data, and we use this to make model. And once the model is developed, we give some features to get the label. Okay. Some unseen feature will be given to the model and we will find some label associated with this. What is unsupervised learning? In unsupervised learning, we use to finding the structure in the training data. So in unsupervised learning, we only have the features, not the model. Sorry, not the label. So these features are used to find the structure in the data. Like you would have heard about the proper orthogonal decomposition or dynamic mode decomposition, like that. So they are what we have the some kind of data. So that data is used to find the structures in the data set. So that comes under unsupervised machine learning. What is artificial neural network or ANN? ANN is a powerful technique in machine learning that is used for both supervised and unsupervised learning. Now, if we go back to our regression problem and consider the simple linear regression, what kind of problem we have there? This is a form of supervised machine learning. Why supervised machine learning? Since we have the data set, in the data set, we have both feature and label. Okay, that's why it is comes under supervised machine learning. So what we do in simple linear regression, we have the data set tau, where we have n points, and based on these and this data set, we want to predict y hat star, which is the estimated value of y at x star. Okay, how we do that? We fit a curve y hat that is equal to w0 plus w1x to the training data. Okay, so this is our what model, Now we give the input and find the output W1, W2, sorry, W0 and W1. And once we get this W0 and W1, we find y hat star at x star, that will be equal to W0 plus W1 x star. Okay. If we represent it in geometrical form, what will be? There is two input in this equation. There is two input. First one is 1, second one is x. Okay. So there is some weight associated with x, that is W1, and there is some bias associated with this, that is W0. Okay. Then what we do? We do the summation of these two terms. We do the inner product of these two and then do the summation. Then we apply some activation function phi to get the output y hat. So the W0 is called as bias, which is multiplied with constant 1, and the W1 is called as weight, which is multiplied with the input x. Okay. And phi is activation function. In this case, phi is nothing but phi z is z only. So if you see this, the green dotted area, this resembles like a artificial neuron, like a neuron we have in our body. So what is neuron? Neuron, a biological neuron, is a unit cell in our nervous system. Okay, that is used to transmit the signal from one point to another in our body. So the network of biological neurons form a complex neural network that is called as nervous system. Okay. So similar to that, a network of artificial neuron with properly selected activation function is called artificial neuron network, or ANN. An individual neuron, biological or artificial, performs simple tasks, but once combined, they form a network that can perform very complex tasks. Okay. Now, if we represent the multiple linear regression in geometrical form, so here we have what? Here we have input in a form of vector x1, x2, dot dot xm, and we have the weights associated with this w1, w2, and so on, wm, with a bias w0. Then z will be what? Z will be summation of w0 plus w1 x1, w2 x2, wm xm. Okay. So this is a geometrical representation of what? Multiple linear regression. So depending upon our problem, we can construct many different structures of artificial neuron, and we can vary the activation function as well according to our need. Now let us see what kind of artificial neuron can be possible. So artificial neuron, sorry, this is not that. So artificial neuron can be used for classification problems. What do we mean by classification problems? Means what? Here we have in regression, what we have? In regression, x belongs to real number and y also belongs to real number. Both input and output belongs to real number. But in classification problem, y is not real, but it is categorical. What do we mean by categorical? Means it is either pass fail type or good bad type, like that. Or in mathematically, if we want to represent, it is an integer like 0, 1 or -1, 1. Okay, so in this case, x belongs to real number, but y belongs to integer in classification problem. Number of classes can be 2 or more. If the number of classes are 2, then it is called as binary classification. If there is more than one class, 2 classes, then it's called as multiple classification problem. Okay. So let us represent now the binary classification, artificial neuron. So here what we have a 1 and bias W not associated with that. And we have a vector X naught, sorry, X1, X2, so on Xm, and the weights associated with it W naught, sorry, W1, W2, dot Wm. Then we find the summation after the inner product of this, that Z will be equal to, similar to the regression, multiple linear regression, Z equal to W naught plus W1 X1 plus W2 X2 and so on Wm Xm. Okay. But here in this case, the activation function is different. What will the activation function? It can be defined in many forms, but here we are defining like that. The activation function phi z is what? It is 1 when z is greater than or equal to 0, and phi z is 0 when z is less than 0. Okay. Now, what will the general structure of artificial neuron? So, an artificial neuron will take a vector input. That vector is x naught, x1, x2, dot at xm, xm equal x naught equal to 1. So it will take a vector input. Then what it will do? It will use vector of biases and weight. There will be a vector of biases and weight w that will be equal to w naught, w2, w3, wn transpose. Okay. Now, then what it will do? It will take input vector and biases and weight vector. What it will do? It will compute a inner product of x and w. So that will give me z that will be equal to w transpose x. Now, once I have the z, then it will apply an activation to produce an output. So that output will be y hat will be equal to the phi z. Phi is what? The activation function. Okay. So in general, it can be represented like that. This is what artificial neuron. Many such neurons work together in ANN to perform complex tasks in machine learning. So many such neurons are combined to do a complex task in machine learning. And that combination of the neurons is known as artificial neuron network. Okay. Now we'll see some type of artificial neurons. So first type that we will discuss is perceptron. So perceptron is what? Perceptron is a type of artificial neuron that is typically used to solve that uses binary step activation function. That can be represented like that, no? Binary step activation function phi z that will be equal to 1 when z is greater than 0, and it will be 0 otherwise. So this perceptron can be used for classification problem. Okay. So what will the learning rule for this perceptron? An optimization algorithm that find appropriate W to minimize the difference of actual and desired output or training data. So here we have known input and output pairs. Based on that, we will use that to find the appropriate W that will give me the minimum difference between the predicted value and the known value. So these artificial neurons may have many models. Perceptron is only one of them. Okay, so is it one of them? NN is what? NN is repetitive interconnected network. of artificial neuron. So let us see the perceptron with one input. So here what we have input x, that is vector x naught and x1 transpose, where x naught is 1. What we want to get, want to get the output y hat, that will be equal to phi z. So our z will be what? Z will be the inner product between w transpose and x. That will be equal to I equal to 0 to n wi xi. Here I will go from 1, 0 and 1 only. This was n equal to 1. So how we will solve this problem? This can be used to solve two-class binary classification problem. Okay, so perceptron generally used to solve two-class binary classification problem. Okay, means what? We have an input xi that belongs to C1 union C2. Okay, C1 is category 1 and C2 is category 2. If W transpose Xi is greater than or equal to 0, then my Xi will belongs to C1 class. And if W transpose Xi is less than 0, then my Xi will belongs to C2 class. Okay, the, the equal sign, the equal to assignment is arbitrary. It can be with this one or this one. It won't change the solution much. And the dividing line, the line that divide this category 1 and category 2, here in our case is point. So this dividing line means what? W transpose x equal to 0 line is known as hyperplane. Okay. Now let us see the learning in the perceptron. In general, any appropriate cost function such as least square may be used to optimize to find W0 and W1. In general, any function can be used. However, in perceptron, a specific learning algorithm is used. What is the algorithm? Suppose we have found the W after kth iteration. So we have the W after kth iteration. Now we wish to find W at k plus 1th iteration. Okay. So what we will do for input xi, we will find y hat I. Okay. For input xi, we will find y hat I, that will be equal to phi of W at the kth iteration transpose xi. Once we found out this, we'll find a loss function. The loss function Li is defined as yi minus yi hat. So based on this, we can say loss function will be either equal to 0, 1 or minus 1. Then after finding the loss function, we'll find new W at the kth iteration, that will be equal to W at the kth iteration plus R multiplied by Li multiplied by xi. This R is nothing but the learning rate. Okay, so Wk will be equal to Wk plus R Li xi. Now we will stop this iteration when our Li will be equal to 0. Okay, and after that, what we'll do, we'll assign Wk plus 1 will be equal to Wk. So from here we'll assign this to W at the k plus 1th iteration, and this will go till we have Li equal to 0. Okay, so this is the algorithm that can be used, that are used in perceptron. Now what is the convergence of this? So the algorithm converges after finite number of steps, provided that the data set is linearly separable. What do we mean by linearly separable? Means the data can be classified by a point in 1D case, or by a straight line in 2D case, and by a plane in 3D case. So what do we mean by that? Suppose in 1D case, I have only one input x. So the data I will have So there must be a point at x, no x, suppose x star, that will classify by signal into two categories. So that is linearly separable. And in the 2D case, there will be a line that will separate the data set. So this is what we mean by linearly separable. In general, a perceptron can accept a vector input of any dimension, right? So we have seen this for only one variable. So in general, it can take a vector also. The vector will be what? That will be x0 to xm, where x0 will be what? 1. Now we will use this training data to compute the weight and biases W. That will equal W0, W1, W2, Wm. And once we get that, we'll use an unseen data to classify. That will also be a vector. Now, what is the difference between the online learning and offline learning? So, online learning uses one training data after another. Like that. Here, what we do? We use one training data. We find the weight. Then again, we use another data to update the weight, like that. So this is what? This is online learning. We use one data at a time, one training data at a time. And what is offline learning? In offline learning, we use all the training data together to find the weight and biases. Like if you remember, in least square regression, we use all the training data together. Then we have found, we have minimized the cost function. Now we will see what are the limitations of this perceptron. So the first and most important, for the perceptron case, you please refer to the lectures. There the professor has solved or shown a computer program, how you can write a computer program for the perceptron to classify, that can be used for binary classification. So what are the limitations associated with perceptron? So perceptron usually have multiple solutions. So suppose if you have the data like that, there is one dividing line like that. So it generally has multiple solution. What do we mean by multiple solution? There are, this solution is also possible, that is, so if this one is solution, this is also a solution, and this right one is also a solution, like that infinite number of partition can be possible. So this is the one limitation with the perceptron, that it has a multiple solution. Second thing, not reliable or test point near the decision boundary. So this can be also a boundary, this can be also a boundary, this can also be a boundary. So if we have the data, unseen data, that is close to the boundary, for some solution it may be falls under C1 class or C1 category, and for some other solution it may fall under C2 category. So that's why it is not reliable close to the boundary. Okay. Now, since perceptron uses all the data points to calculate, to find out the weight and biases, it is sensitive to the new data that may be an outlier. Suppose this is my boundary, these are my data. So maybe new data come in this range. So this boundary will be affected by this data also, although this is a kind of outlier. So this may change the solution. So this is one issue, that it is sensitive to new data. It is sensitive to outliers. But a machine learning model, what should do? It should neglect the outliers. Okay, so that the perceptron are not able to neglect the outliers. And last but not the least, the most important thing, that the perceptron only works on linearly separable data, but that is not always the case. Most of the times we may have linearly inseparable data. What we do in that case? The possible remedy is what? We will use artificial neuron network, ANN, in which what we'll do? We will combine multiple perceptron to classify the data that are not linearly separable. Okay. Now, what is artificial neuron network? We'll see. So this is nothing but a bio-inspired model of computation. So ANN is what? As we discussed earlier, ANN is what? Is a repetitive interconnected network of artificial neurons. Artificial neurons is what? Unit cell kind of thing. So it artificial neurons, what we do, it optimize to find the W0 and W1. So let us see an example of ANN. So this is a typical type of ANN, which is feed forward neuron network. Okay, so it has some input layer, has some output layer, and between that it has some hidden layers. Okay, so this is a input layer, output layer, and in between some hidden layers. Okay, this each nodes here, this each nodes is what? This each node is artificial neuron. So what each node is doing? Each node is calculating its own weights and biases. Okay, and it takes some input and provides some output. So what is feed forward neural network? This is unidirectional. Means what? Unidirectional means what? The information flows from input to output, not the other way around. If you see here, the information from this node is going there, 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 like that in every node, but it is not coming back. From here, it is going in the output direction only. It is going like that. So feed forward is what? Unidirectional flow of information. When there is a unidirectional flow of information, the artificial neural network is called as feed forward neuron network. Okay. So what is hidden layer? The layer in between input and output layer is called as hidden layer. Okay. Hidden layer also have its own bias node. Each node acts as an individual neuron and process the input data as phi W transpose X. So what we do, the ANN is trained using the training data, and once we have trained, ANN is trained using the training data. What we do during training, the ANN learns optimal value of W for each layer. Okay, for each layer is learned the W, and once once the learning is completed, the ANN is developed to predict the output of unseen test data. So what we'll do, first we train the ANN using the training data, and what it do during the training, it find the optimal value of W at each layer. Once it is completed, it is giving an unseen data. So unseen test data, for that it provides the output. Okay. Now we will see some type of activation function. There are several options are available. Only few we will see here. So first activation function is sigmoid activation function, which is equal to phi z, that is equal to 1 minus e to the power minus z. So if you put here infinite, so e to the power minus infinite will be what? It will be 0. So 1 minus 0 will be what? 1. So 1 divided by 1 will be what? 1. So if you put infinite to, it will goes to 1. So here it will go to 1. If you put 0 here, if you put minus infinity, it will go to 0. So sigmoid will vary from 0 to 1. It goes to 0 when our z is minus infinity, and it goes to 1 when our z is infinite. Similarly, hyperbolic tangent, that will be phi of z will equal to tan hyperbolic of z, that will equal to e to the power z minus e to the power minus z divided by e to the power z plus e to the power minus z. If you put infinite here, it will go to 1, and if you put minus infinite, it will go to 0. So tan hyperbolic will look like this. Now another type is rectified linear unit, RELU, ReLU, that will be equal to phi of z will be equal to z when z is greater than or equal to 0, and it will be equal to 0 otherwise when it is less than 0. It can be represented like that also, 1 by 2 mod of z plus z. So if z is greater than 0, the mod of z will be what? Z only plus z divided by 2. So it will lead to what? It will lead to z, and when z is less than 0, my mod of z will be what? Minus z plus z 1 by 2. So it will be called 0. The next type of activation function is soft plus activation function, where phi z is what? ln 1 plus e to the power z. So it is nothing but the approximation of ReLU, rectified linear unit, with differentiable function. Okay. So ReLU will be what? 0. So this green one is what? ReLU, and this red one is my soft plus. And we have also seen the binary step, that is equal to phi z will be equal to 1 when z is greater than or equal to 0, and it will be equal to 0 when it is less than 1. Identity, like we have seen in linear regression, phi z will be equal to z only. And there are many more type of activation functions are available. Now what we'll do, now we will solve some problems. Okay. So the first problem is what? In supervised machine learning, each training data includes option A, features and label, option B, only features, no label, option C, only label, no feature, option D is features, label, and hypothesis. So let us see. So we have discussed this now. So supervised machine learning. So it uses features and label both. So this will be my correct answer. Huh? This is my correct answer. Supervised machine learning uses both features and label. Similarly, unsupervised machine learning, it uses only features, no label, to find the structure in the training data. Now, next problem. Using training data xi, yi, I goes from 1 to n, means what we have training data set. We wish to find the value of y at x equal to x star, where y and x star are real numbers. Okay, they are real number. The problem of finding y at y star is what? So when y is belongs to real number and x is also belongs to real number, the problem is what? The problem is regression problem, not the classification problem. Similar to that problem, the training data xi, yi, I goes from 1 to n. We wish to find y at y star, but here yi is categorical. Categorical. It is not real. So if it is categorical, then the problem is what? My classification problem, not the regression problem. The next problem, is you can see the next problem, I guess. So the next problem is for artificial neuron with input x and output y equal to f of z, where z is equal to what? W naught plus w1x, and y is equal to what? Y equal to tan hyperbolic of z. So for w naught equal to 1, w equal to 1, and x equal to 1, what will be the value of y? We need to find the value of y. Let us find the value of. So z is what? Z is w naught plus w1 x. So let us put the value here. So z will equal to 1 plus 1 multiplied by 1. Sorry, let us put what's x here only. X. So it will equal to 1 plus x. So now at x equal to 1, z will be equal to what? 2. Now once z is 2, y will be what? Y will be tan hyperbolic of 2. So if you find the tan hyperbolic of 2 value, that will be equal to what? That will be equal to, if I put the value in the calculator, tan hyperbolic of 2. Where is tan hyperbolic? Yeah, so it will be equal to 0.964. Okay, so our answer will be what? 0.964. This will be our answer. Now the next problem. Artificial neuron with input and outputs, input x, output y. Z is defined as w naught plus w1x. Y is defined as tan hyperbolic of z. Here the w naught is same 1, w1 is also 1, but my x tends to infinite. Okay, x tends to infinite. So what was the value that I have found? My y was tan hyperbolic of 1 plus x. This is what will be at w naught equal to 1 and w1 equal to 0, 1. So if I put this to infinite, that will be equal to tan hyperbolic of infinite. That will be equal to nothing but 1. It will tends to 1 when it is infinite. Tan hyperbolic of infinite will be 1. Similar to that, this problem is same, but here our x is going to minus infinite. So in this case, y will be what? tan hyperbolic 1 plus x, x goes to minus infinite, that will lead to y will equal to minus 1. Here it is 1, here it is minus 1. Now the next problem, for artificial neuron with input x, output y, y is f of z, where z is equal to nothing but what? W0 plus W1 x. Y is defined as ReLU of z. So what will be the value of y when W not equal to 1, W1 equal to 1 and x equal to 1? So first, what will the value of z? Z will be equal to W naught plus W1 x. Okay. So from here, what will be my y? Y will be what? Y will be ReLU of W naught plus W1 x. So it will be equal to what? It will be 0 if the whole term W naught plus W1 x is less than 0, and it will be equal to W naught plus W1 x when the whole term W naught plus W1 x is greater than or equal to 0. Okay, so now we put this value here and find this. So z will be what? If you put both of them to 1, so 1 1, so it will be 1 plus 1 multiplied by 1, that will be equal to 2. This 2 is what? Greater than 0. So my y will be equal to nothing but y will be 2 only. Next problem is same, but here W naught and W1 is minus minus. Both are minus. So let us put the value. So what will be my y? Y was the ReLU of W naught plus W1 x. That will be equal to ReLU of minus 1 plus minus 1 multiplied by 1. So that will be equal to ReLU of rectified linear unit of minus 2. So it is less than 0. It will be equal to 0. So my y will be equal to 0 in this case. Last problem, for artificial neuron with input x and output y, we need to find the value of y for finite value of the W0 and W1 when x goes to infinite. Okay, so here in this case, my y is what? ln 1 plus e to the power z. So z will be what? W0 plus W1 x. Now if you put the, when x tends to infinite minus infinite, my z will also tends to minus infinite. It means what? My y will be equal to ln of 1 plus e to the power minus infinite. So this will go to what? 0. So that will be equal to ln of 1. ln of 1. So y will be what? Nothing but 0. So this will be 0. So in this week, the problems are very simple. The problems was very simple, but the theories was important. So in this week, The instructor tries to give some basic introduction to machine learning and ANN. Okay. Now what we'll do, we'll do a practice problem. This practice problem is what? This practice problem is what? We'll write a computer program that will use standard random generator to generate a random number that are linearly separable in two-dimensional space. Okay, this is what we want to do. So we want to generate random numbers that are linearly separable using standard random generator. Okay. So let me stop here from here. I will share from my computer. Share screen. I hope you are able to see my screen now. What we need to do here, we need to create a linearly separable data set, 2D two-dimensional data set using standard random number generator. Okay. So before doing anything, I will close if I have opened anything. Close all. I will use generate the random numbers. Suppose I am generating x1, that will equal to rand. This rand function, what it will do, it is an input variable that will generate random number between 0 to 1. Okay. So number of points that we want to generate, first let us write. So number that will be equal to, suppose I am taking 1000. So 1000 point we will generate. So x1 will be equal to rand of that will generate x1 1000 point between 0 to 1. So similarly x2 and y2 also I want to generate. Convert. See. Y1. So I have generated four random variables. Now what I will do, so these point, this x1 and y1, these are 0 to 1. This x2 y2 is also between 0 to 1. If I take shift that is equal to 2, suppose, what I do, x1 what I do now, if I do x1 is equal to x1 plus shift. So what I am doing now, I am shifting my x1 that is belongs between 0 to 1. Not what I am doing. I'm making it between 2 to 3. Similarly, y1 equal to y1 plus shift. So y1 will be also between what? 2 to 3 now. Now my x1 and x2. So x2 suppose 2. Now I do not plus shift, minus shift I do. So by doing minus 2, my x2 and y2 will lie between. Now it will lie between what? 0 so minus 2 to minus 1. Now it will lie between minus 1 and minus 2. So I have generated now the random variable that are linearly separable. Let us see whether it is or not. Figure. I will open a new figure. Similarly, I need to hold on this figure, the scatter that has been generated. I run this F9. Okay, so I have put so these are my random number. So they are linearly separated. No? This belongs in this section, this belongs in this section. This is my random number. Okay. I hope this is clear now. So now what we'll do, we will see the last week problem of Newton method for the optimization problem. There we have solved the problem, but we haven't seen how the plot will look like. So the beauty of Newton method is that it immediately jumps towards the optimal solution. So let us see. So what was the case there? So we have some function x square plus 2y square minus 2xy minus 2x that leads to descent direction x minus 2 by 3, y minus 1 by 3. So we want to minimize this function. So what we did here, while the norm of descent was greater than epsilon, we did x equal to h descent of 1 and descent of 2. And descent is defined as descent direction x or y. So like that we have defined now. So if I run this, it has converged after how many? 50, I think here it is written. No? It has converged after 55 iterations. And at minimum point, the x is what 2, y was 1, and minimum value was minus 2. How the plot look like? Now we'll see. So this is how the plot should look like. If I see the x value first, so I started the x with 50 and 50. Is decreased rapidly in some iterations, then close to 2 from here. I think it is quite close to 2 and it quite close to 1. It has optimized it. Okay, so after 55 iteration it has been optimized. So this is what it has been started from here 50-50. Then it move like that, like that. Then it has been converged. If you see in the 3D, in 3D it has been started from here and it goes like that. Okay. So this is the path of the point. Clear? This is what we wanted to discuss in this week. What has been discussed this week? This week we have discussed fundamentals of machine learning and artificial neural network as a machine learning tool. So what are the models we have seen? Model was used for prediction and it is based on some conservation principles that we have seen. So we have seen that when the mechanistic model is not available, but we have the experimental data, then machine learning is useful in that kind of scenario. So what is machine learning? Machine learning is nothing but a computer program. Machine is computer program, and learning is what? It improves itself. It improves the prediction with experience. So a computer program is set to a machine learning program if its performance at task T improves with experience E. Okay. So when it is desirable, when we do not have any model to describe the process, when the model is incomplete, or the model is too complicated, or the model is ill-posed. Then we have seen the difference between the traditional model and machine learning model. In the traditional model, we know the underlying mechanism, but here we do not know the underlying mechanism. In the problem, we have the input, we want to find out the output, but in machine learning we have the input and known solution. Based on this, we train the data, we trained our model so that when the unseen test data come, it should able to predict an output. In the traditional models, the models are rigid, but the boundary condition and algorithm we can change. But here in machine learning, the model itself is flexible. It changes with experience to give us good results. And how which kind of experience for the bad predictions. So it always try to predict the value. So most of the times there are probability involved in the prediction. That's why it is probabilistic in nature, while the traditional model are deterministic in nature. Then we have seen supervised machine learning, unsupervised machine learning. What is ANN? We have represented in a geometrical form of simple linear regression that looks like a neuron that is present in our body. So we set this to a, we have named this to artificial neuron. Okay, and the combination of repetitive artificial neurons is called as artificial neuron network. Individual neurons perform simple tasks, but the combination can perform very complex tasks. Then we have represented in geometrical form multiple linear regression. Then we have seen how this artificial neuron can be used for classification problems. In classification problem, this output y is belongs to integer, not real number. The classification can be of multiple type of classification or binary type of classification. If there are two classes only available, it is called as binary classification. But when there are more than two type of classification available, then it is called as multiple classification. We have represented in geometrical form of artificial neuron for binary classification. Then we have seen what are the general structure of an artificial neuron. So there are four things that is involved in that. First one is it takes an input vector input, uses a weight and biases, then computes the inner product between the x and w, then applies a activation function to predict the output. So this is a typical neuron network. Many such neuron network together in ANN perform complex tasks in machine learning. Then we have seen a type of artificial neuron that is known as perceptron. Perceptron can be used for solving classification problem. We have seen the algorithm that is used to learn in perceptron. There we try to minimize the loss function, that is difference between the known value and the predicted value. We try to minimize this loss function. So this is what the algorithm for perceptron. Here one R is involved, that R is known as learning rate. In general, perceptron can be used for vector input as well. First we have seen with single variable. So by using that, we predict what W0, W1 like that, weights and biases. From the training data, we predict this weight and biases. And once we get this, then if unknown data set came, unknown test data comes, we can classify that. Then we have seen what is the difference between online learning and offline learning. So what online learning do? And online learning uses one training data after another, while the offline learning uses all the training data together to compute the weights and biases. Then we have seen what are the limitations associated with perceptron. First limitation was what? It has multiple solutions. So the dividing line, the boundary is not unique. There are multiple boundaries. So the perceptron is not reliable close to the boundary, close to the decision boundary. And as a machine learning model, it should neglect the outlier, but perceptron uses all the data to compute the decision boundary, so it is sensitive to the outliers. Then last but not the least, the perceptron works only for the linearly separable data. So how we can solve this problem? The possible remedy is using artificial neuron network. Here what we do, we combine multiple perceptron to classify the data that are linearly separable, linearly not separable. Then we have seen what is the structure of artificial neuron network. Here we have seen feed forward neural network, which is nothing but a unidirectional flow of neural network. Means what? The information flows from input to output, not the other way around. It has input layer, output layer, and in between there are hidden layers. So hidden layer, each node is what? Artificial neuron. So it has its own bias and weights. Each node acts as a individual neuron that calculate phi activation of W transpose X. So what we do in N is trained using the training data. During training, optimal value of W is calculated at each layer. Once W is known at the layers, at each layers, what we do, we predict the output for unseen data. Then we have seen some type of activation functions. Then what we do, we solve some easy problems that are related with the theories that has been covered in Week12. Then what we have did, we have written a computer program that can be that uses standard random generator to generate linearly separable two-dimensional data. Okay, so now what we'll do, we will try to what we will do, we will try to write a computer program for this algorithm. Okay, so we'll use some xi and yi input data. Okay, so let me stop share from here. Code for binary classification using Perceptron. Okay, so first what we'll do, first we'll close everything, close all. Yes, clear the command window and they clear the variables that are available here. So clear all. Then we will define the variable input data set and variables. Okay, so we will define x, will define y. So x will be what? Integer. No, x will be real number, y will be integer. Then suppose I need to define now x, na. So just give me 1 second. I need to use the training data set. So let me write the training data set. Wait for 1 second. So what is my training data set? What is my training data set? Let me write where it is. Okay. So we will use the same problem, propellant age and shear strength. So x is what my here? It's 15.5, then 23.575, 8, 17, then 5.5, 19, 34, 2.5, 7.5, 11. Corresponding y is what? 1, 1, 0, 1, 0, 1, 1, 0, 0, 0. This is what I have. So let me share the screen again. So 15.5, then 23.75, then 8, then 17, 5.5, 19, 24, 2.5, 7.5, then 11. Corresponding y is what? 1, 1, then 0, then 1, then 0, then 1, then again 1, 0, 0, 0. This is my data. Now what I need to do here in the algorithm? Since we are using the loop, so I need to define the maximum iteration. So suppose the maximum iteration is what? 10,000. Sorry, 1 lakh here. This is my maximum number of iterations. Now I need to define what? I need to define now W. So W will be what? Suppose initially I am assigning W as 0, 0. So this is my W. I need to define the learning rate. So the learning rate R, I am defining here 0.01. Now learning rate is defined. So for I equal to 1, to maximum iteration, I will do. Okay, now I need to define what? I need to find what is the number of variables, number of data that is available here. Then will equal to length of is the length of x. So I will use here what? So y hat will be what my loss function L will be what? Suppose I am defining as initializing it as everywhere it is 1. This is my loss function. Now I have defined the loss function. Now what I need? R I have already defined, W I have already defined. Now for j equal to 1 to n, I will find B that will be equal to norm of L. I will find norm of L if B equal to 0, break. B will be now first I need to calculate what? I need to calculate Z. So Z will be equal to what? W naught plus W1. W naught plus W1 X. So Z will be equal to what? W first plus W multiplied by Xj. So I have found out what? I have found out Z. Now if my Z is greater than or equal to 1, greater than or equal to 0, my what? Y hat will be what? Y hat will be what? 1, else Y hat will be what? Y hat will be equal to 0. And now I have calculated the Y hat based on Z. So I have here what I have done? I have applied the activation. Activation. Okay. Now what I will do? I have found out the now my X will be equal to X in will be equal to what? First variable and X j. This is my x in. Now once the x in is defined, I will define the loss function. Oh, I need to define first the loss function. Loss function will be what? L of j will be what? Y of j minus y hat. Okay. Now I need to find the W new. So W new will be what? W will be what? Whole W plus learning rate multiplied by Lj multiplied by x in. Okay. So this is what my W. W is fine. But it in each loop it will calculate the W. Once the W is calculated, it will check if my B is equal to 0, it will break. Otherwise, it will go and again calculate the norm of L. Once the norm of L is calculated, then what it will do, I can calculate control X. Here also I can calculate the norm. It will calculate the norm of L. If B is equal to 0, it will break. Else it will continue. So what I want to display? I want to display W after each iteration. Then I need to show the decision boundary. The decision boundary will be what? W1 that will be at y equal to 0. So it will be what? W minus W0 divided by W1 minus W0 divided by W1. This is what my this is what I have. So I should run it now. F9. So if you see here, it has been converged after 7 number of iterations. And what is my W at this point? My W0 is minus 0.1200 and W1 is 0.1. Add this, my what? My X separation is what? Is 12. Okay, this is 12. So if I plot my data, whatever the data I have, if I plot here, if you see the data is 0 from here to here, and it is jumped to 1 from here to here. So 12 is lying somewhere here. So 12 is defining the x separation. Okay, this 12 is defining the x separation. So I can also garnish this by adding a line. I just want to draw a line. I'm just defining a variable like that, so that will be equal to 12. So this is like that. No? So this is my answer. These are my data. This is my X separation. So if we do this for multiple variable, means the input is not single variable, it is what? Vector. Then what will be the case? The algorithm will be same only. Only there what will be? There I think we need both, no? W0, W1 and W2. Then we need to find W0, W1 and W2 both. So let us do that also. So in that case, I have another variable is with age we have also temperature also. So temperature also we have, na? So temperature also we have. So what is the value of temperature for each case? In degree centigrade 40, then 23.25, 17, then we have 21, then what we have? We have 10, then 12, then 20 again, 12, 15, 26. Let me save this. Control A, Control C. Now I have temperature as well, na? So two variable we have. So temperature is what? So I need to define the temperature as well, na? So temperature is what? 40, then 23.25, then 17, 21, 10, 12, 20, 12, 15, then 26. Okay, just 1 second. My y is also changed in this case. So my y is what? Here in this case, my y is what? My y is what? 0, 0, 0, 1, 0, 0, 1, 0, 0, 1. Okay, so 1, 1, 0, 1, 0, 0, 1, 0, 0, 1. Okay. So 1, 0 1, then 0 0, then 1 double 0, then at last it is 1. So this is by two variables. Now what I need to do, I need to define W as three terms now. Learning rate will be same, this will be same, and will be same. Now in this case, my Z will be what? W1 plus W3 multiplied by what? Tj. Now then this will be the same. X in will change. This will be the same. Everything else will be same, but my separation line will be different. My separation line will be what? My separation line will be what? W0 plus W0 plus W1 X plus W2 T. That will be equal to 0. So from here, if I want to find the T or X, T as a function of X, that will be equal to what? Minus W1 upon W2 X minus W0 upon W2. So this will be my line. Okay, now let us do that. So my separating line will be what? So T separation in this case will be what? Separation. When my Z will be 0, Z will be 0 will represent the separation line. So from here, if I find the Tj value, so my T separation will be what? Will be in bracket minus W2 divided by W3 multiplied by X plus minus W1 divided by W3. So I should comment this. Unrecognized T separation variable वो तो स्पेलिंग में गड़बड़ी है कुछ. So this is my T separation line. Now, and what is my W values? W0 is minus 3.88, W1 is 0.14, and W2 is 0.09. So this is my W0, W1, W2. Now I need to plot this. So think I have made some mistake. So there will be a separating line in T also and X also. I think you got the point. So this is what we have discussed. We need to discuss in this week. So throughout this course, what we try to do, throughout this course, what we have run, we have learned how we can develop simple model in how to develop a model to a simple engineering problem. Then we have seen how to solve the above model numerically and write its computer program. Then we have also seen some theoretical aspect of mathematics that is behind this numerical methods. And what are the limitations of the numerical method also we have seen. So suppose we have particular numerical method we have developed. So when it will converge, when it will not converge, what is its stability, what is convergence criteria, all that we have seen. So by completing this course, you would be able to learn that how to make a model of simple problem and how to solve them numerically and writing it by writing its computer program. So I like to congratulate you for completing this course. Okay, so I will stop now. Thank you so much. But next week, I think on Sunday, same time, we'll have an extra class. There, what we'll do, we will revise the topics that has been covered in this course, and also the major topic that can be asked in the exam that we will discuss. Okay, the main topic we'll discuss. So I'm stopping now. Stopping the share now. Thank you so much for joining.